Have you ever found yourself just writing the same line of code again and again and again? It's so tedious, right? And honestly, it's not what programming is all about. So today, we're going to dive into one of Python's most powerful tools for automation, loops. Get ready to learn how to make the computer do all that repetitive work for you. So here's the game plan. We're going to start with the big idea, the philosophy behind why we even need loops. Then we'll get into what they are. After that, we'll break down the two main types, the for loop and the while loop. And we'll wrap it all up with some pro tips that'll give you really fine-grained control over your code. Before we write a single line of a loop, we got to understand the why. And it all comes down to this one fundamental golden rule in software development. This, right here. This is the mantra. It's known as the DRY principle, DRY. And seriously, if you find yourself copying and pasting code, that should be a little alarm bell in your head telling you, hey, there's probably a much smarter way to do this. And look, this isn't just about saving a few keystrokes. The real win here is that when your code is less repetitive, it's so much easier to read, to update, and to fix when something goes wrong. Think about it. If you need to make a change, you do it in one single spot, not in 10 different places. Okay, so if repeating yourself is the problem, what's the solution? Well, in Python, the answer is simple: loops. Let's take a look at what these things actually are. At its heart, a loop is just you telling the computer, hey, see this chunk of code? Do it. Again and again, and keep doing it until I say stop. Computers are absolute masters at this kind of stuff. They never get bored, they never get tired, they never make a typo on the 100th time. And loops let us tap directly into that power. Now, Python gives us two main tools for the job, the for loop and the while loop. The way to choose between them is actually pretty simple. You use a for loop when you know exactly how many times you want to do something, like print this message 5 times. You use a while loop when the repetition depends on some condition, like keep asking for the password as long as it's incorrect. Let's start with the for loop. This is your workhorse, your go-to tool when you have a definite, predictable number of times you need to run some code. And the engine that really makes it go is a super handy function called range. What's so cool about range is how flexible it is. You can just give it one number and it'll count up from 0. Or you can give it a start and an endpoint. You can even give it a third number to control the step, like counting by 2s or 5s. And here's a little insider tip. Range is incredibly efficient. It doesn't actually create a giant list of numbers in memory. It just generates them on the fly, one at a time, exactly when the loop needs them. Pretty smart, huh? And you can see here exactly how that plays out. Notice with range of 6, you get 6 numbers, but it starts at 0 and stops just before 6. That's a classic Python thing to remember. And check out that last example. You can even use a negative step to count backwards. It is just incredibly versatile. All right, let's see this thing in action. Classic example, a rocket launch countdown. We use a for loop. We tell Python to count backwards from 5. On the very first pass, what we call an iteration, the loop kicks off with our first value. Then the loop just automatically moves on to the next number in the sequence, 4, and runs the exact same code all over again. And again, for 3, you see this? This predictable step-by-step march is the for loop's superpower.
It just keeps going, executing for 2.
And finally, it runs the code for the very last number in our range, which is 1. And then what? Well, once the loop has worked its way through every single number in the range, it just stops. It's finished. And the program moves on to whatever's next. Simple, clean, predictable, and super powerful. Okay, so we've met the predictable for loop. Now let's switch gears to its counterpart, the while loop. Think of this one as the vigilant watcher. You use this when you don't know how many times you'll need to loop, but you do know the condition that should make it stop. The logic here is a constant checkup. First, Python looks at a condition. Is it true? Okay, if it is, it runs the code inside the loop. Now, this is the most important part. Something inside that code has to eventually change the thing that's being checked, because then Python goes right back to the top and checks the condition all over again. This cycle repeats over and over until that condition finally becomes false. So this brings us to a really, really important and sometimes kind of dangerous question. The while loop is patiently waiting for a signal to stop. But what happens if that signal just never arrives? Yep, you get an infinite loop. This is the one where your program basically gets stuck, repeating the same code forever and ever. Imagine that password example. The loop continues while the password is not correct. If you forget to actually let the user type a new password inside the loop, they're stuck forever. That's why it is absolutely critical that something inside your loop gives it a way out. All right, you've got the two main types of loops down. Now, let's cover a couple of quick pro tips that will make your loops cleaner, more efficient, and give you much more precise control.
First up, don't let the fancy name augmented assignment operators scare you. This is just a super convenient shortcut. Instead of writing out x equals x plus 10, you can just write x plus equals 10. It does the exact same thing, but it's cleaner, it's faster to type, and it's perfect for updating variables inside your loops.
And finally, two incredibly powerful keywords, break and continue. Think of break as the emergency escape hatch. The moment your code hits the word break, it immediately blasts out of the loop, no matter what. It doesn't even check the condition again. Continue is different. It's more like a skip button. It stops the current trip through the loop and tells Python, all right, skip the rest of this one and jump straight to the start of the next iteration. They are essential for fine-tuning your loop's behavior. So let's wrap this up. We've seen how loops are amazing at automating repetitive tasks, but their real power is how they change the way we think about solving problems. Which leads me to this final thought for you. Loops aren't just for doing things over and over. They can be part of a much smarter strategy for finding things, like bug. Instead of just checking every line one by one, how could you use these ideas to maybe divide and conquer the problem? Something to chew on.